Good evening, students. Good evening. Are you guys able to hear me?
Yes, sir.
Good evening, sir. Good evening.
Sir, every time the product of two vectors is a scalar quantity, or only
No,
in
no,
some
no.
cases?
Only when you do dot product between them. Okay. I'll come to that point. What exactly does that mean? Okay. Suppose I give you a vector like this. A vector is equal to a1 I cap plus a2 j cap plus a3 k cap. Okay. This is a general vector. And b vector is equal to b1 I cap plus b2 j cap plus b3 k cap. Okay. Then a vector dot b vector is given as a1 I cap plus a2 j cap plus a3 k cap dot b1 I cap plus b2 j cap plus b3 k cap. Okay. Now this will be equal to how many terms do you have here? You have 3 terms
2 to 6.
multiplied.
3. Yes, sir.
So totally how many terms will you get? You will get 9 terms, right? So what are those 9 terms going to be? So whenever a vector is given in its standard form, this is called as a vector form. I think I've already told this to you guys. So whenever the vector is given in its standard form, this A1 is called as the scalar part, I cap is called as the vector part, the orthogonal unit vectors. So here, first I will multiply A1 I cap with this whole vector using the dot operation. Look at the way I'm going to do, okay? So I can write it as A1 into B1, means I'm multiplying the scalar parts, and between the vectors, I'm doing the dot product. Because between the scalars, it doesn't make sense. So A1 B1 into I cap dot I cap plus A1 B2 into I cap dot J cap plus A1 B3 into I cap dot K cap. Clear? Plus. You guys tell me. A2 B1 J cap dot I cap plus A2 B2 J cap dot J cap plus A2 B3 J cap dot K cap.
K cap, yes, sir.
Yeah. Similarly, A3 B1 K cap dot I cap plus A3 B2 K cap dot J cap plus A3 B3 K cap dot K cap. Okay. Now listen to this carefully. Okay. This whole thing I'll call it as 1. Now I'm going to check what is I cap dot I cap. So I cap is an orthogonal vector and the other I cap is obviously an orthogonal vector. So what does A vector dot B vector tell us mathematically? Magnitude of A vector into magnitude of B vector into cos theta. Correct? Theta is the angle between those two. So
Yes,
here
sir.
can I write it as magnitude of I cap into magnitude of I cap into cos of the angle between I cap and I cap. What is the angle between I vector and I vector itself?
180.
It is 0. Because I cap is in which direction? Positive x-axis, and the other I cap is also in the positive x-axis. So they are going to look something like this. So
Sir,
the
it
angle
can
between them,
coincide, right?
yeah, they can coincide. Yes, they'll be like this actually. Okay, because they are representing the same vector. So what is the magnitude of I cap?
1.
1, and magnitude of the other I cap is also 1. Magnitude of cos 0 is 1. Okay, the answer will be 1. In a similar way, can I say J cap dot J cap is also going to give you a 1? In a similar way,
Sir,
K
but
cap
1
dot,
doesn't give the direction, right?
No, it will not give. That is what I told. No, when you do the dot product between two vectors, it will give you a scalar output. That is why dot product is called as a scalar product. It's giving a scalar output. No, one. One is a scalar. Okay. Now listen. Now comes the next question. I cap dot j cap is how much? Magnitude of I cap into magnitude of j cap into cos of, what is the angle between them, guys?
90 degrees.
Obviously a 90 degrees. So magnitude of I cap is 1, magnitude of j cap is 1, and cos 90 is going to be a 0. So from this, I can conclude one important point. What is it? If you do the dot product between two perpendicular vectors, if you do the dot product between two perpendicular vectors, the answer is 0. Correct?
Yes, sir.
Right. So out of these 9 terms, which are all the terms that are going to exist and which one will get eliminated?
The 6
So
I
terms
cap
will
will
be
get,
0.
so I dot j, I dot k will get eliminated. J dot I and j dot k will get eliminated. K dot I and k dot j will get eliminated. So the terms that are left out with this, and this. So what will you get, guys? A1, B1 into, in the place of I cap dot I cap, can I replace it with a 1? So it is going
Yes,
to be
sir.
A1, B1 plus A2, B2 in the place of j cap dot j cap, I can replace it with 1. A2, B2 plus A3, B3 into place of k cap dot k cap, I can again replace with 1. So the answer for the dot product when the vectors are given in the standard form is nothing but the product of these scalar parts of the corresponding coefficients. So please make a note of this. I'll tell you how to solve the problem based on this. I'll tell you how to handle them.
Sir, could you go to the previous page?
This one?
Yes, sir.
Okay. Should I go down?
1 minute, sir. Let me know once you're done. So let me know once you're done, guys. I hope everybody has copied it, right? Let's see an example. If work done is given as dot product of force and displacement, then find work done when F vector is equal to 2 I cap plus 3 j cap plus k cap and S vector is equal to I cap plus J cap minus K cap. Okay. So shall we do? So what is the work done? It is F vector dot S vector. So what is F vector dot S vector, guys? 2I cap plus 3J cap plus K cap dot I cap plus J cap minus K cap. Okay. So according to the dot product between two vectors which are given in standard form, what are we able to understand? That when you do the dot product between these two, the product of I cap and I cap, the product between the standard vectors is nothing but the product of the coefficients of I cap in both the cases. So here the coefficient is 2 and here the coefficient is 1 plus. Here the coefficient is 3 and here the coefficient is 1 plus. Here the coefficient is 1 and here the coefficient is minus 1. So 2 plus 3 minus 1 is how much? Is 4. 4 generally, if it is taken in Newton and this is taken in meter, it is 4 Newton meter or 4 joule. Okay, that is the amount of work done. Clear, guys? Okay. Now we will see some properties related to dot product. If you guys have copied this, I'll explain you the properties related to dot product.
Yes, sir.
Okay. So write down properties of dot product. First, if
Sir, I have a doubt in the previous question, sir.
please tell me.
Sir, then what about the angle?
No need of angle because they are given in the standard form. If the question is about the angle, then you need to worry about the angle. By using the concept of angle only, you understood what is going to be the formula between two vectors when they are given in the standard form.
Yes,
Is
sir.
there
Yes,
any?
sir. Okay.
Got it? Yeah. If A vector is equal to A1, see, I'm repeating the definition again. That is the only thing. A1 I cap plus A2 J cap plus A3 K cap, and B vector is equal to B1 I cap plus B2 J cap plus B3 K cap. Then A vector dot B vector is given as A1 B1 plus A2 B2 plus A3 B3. Okay. Second, I'll write it like this. A vector dot A vector is equal to magnitude of A vector into magnitude of A vector into cos 0 degrees, which is nothing but magnitude of A vector square or A square. Okay, this is also an important thing. So wherever you find the square of the magnitude of square of a vector, the inner meaning of it is nothing but you have done the dot product between the vector and itself. Example, from parallelogram law of vectors, what is the formula for R? It is root of A square plus B square plus 2AB cos theta, right? Actually, you can also write it as, in the place of A square, I can write it as A vector dot A vector. In the place of B square, I can write it as B vector dot B vector plus 2 times AB cos theta is nothing but A vector dot B vector. This is an other way of writing, but generally we don't prefer it. You write it like this only. But for you to understand the meaning of how to use the second property, I explained it. Clear, guys?
Yes, sir.
So that is A vector dot A vector. So that is the dot product of vector with itself is the magnitude of the vector square. That is the meaning. Okay. Dot product between two perpendicular vectors is 0. So it is very simple. Why is it so? A vector dot B vector is equal to magnitude of A vector, magnitude of B vector into cos 90. Hence, it is going to be 0. And make a note here. This is also a condition for perpendicularity. This is a condition for perpendicularity. Means sometimes what they will do is they will give you two vectors and ask them to find if they are perpendicular or not. That time what you can do? You just find the dot product between them. If the answer comes out to be 0, they are perpendicular. Else they are not perpendicular. Let's take an example. Check if A vector is equal to I cap plus j cap and B vector is equal to I cap minus j cap are perpendicular. Okay. So solution for this is A vector dot B vector is equal to I cap plus j cap dot I cap minus j cap. So what will you get, guys? I cap dot A cap is 1 minus j cap dot j cap is 1. So answer will be 0. Hence they are perpendicular. Clear?
Yes, sir. If A vector dot B vector is equal to magnitude of A vector into magnitude of B vector times cos theta, that implies cos theta is equal to A vector dot B vector, the whole divided by magnitude of A vector into magnitude of B vector. Okay. So somebody asked me about how to find the angle, right? This is the formula that you can use to find the angle. Let us take an example itself. So F vector, how much is it given in that problem? 2i cap plus j cap plus, 2i cap plus 3j cap plus k cap. S vector is how much? I cap plus j cap minus k cap. So what is going to be the angle between them? Using the formula, cos theta is equal to F vector dot S vector divided by magnitude of F vector into magnitude of S vector. So in the numerator for F vector dot S vector, apply the formula like A1 A2 plus B1 B2 plus C1 C2. So what will you get, guys? 2 into 1 plus 3 into 1 plus 1 into minus 1, the whole divided by wait, this is the point I forgot to mention yesterday. The magnitude of any vector is square root of the sum of the squares of these values. Okay. Why it is so? I'll explain it now. 4 plus 9 plus 1. Similarly, you tell me what will be the magnitude of S vector. Square root of 1 plus 1 plus 1. Guys, tell me if you have understood the denominator part alone. Why the magnitude is calculated like that, I'll explain it.
Sir, I cannot understand.
Okay, nothing. If A vector is equal to AI cap plus BJ cap plus CK cap, then magnitude of A vector is given as root of A square plus B square plus C square. That is what I applied. Okay. Why it is so, I'll explain it. After this step, I'll explain it after this point. Now we are clear? So you can apply it for both and see. Square root of 2 square plus 3 square plus 1. That is square root of 4 plus 9 plus 1. Similarly, here it is square root of 1 plus 1 plus 1. So what will be the value of cos theta, guys? 2 plus 3 minus 1, the whole divided by square root of 14 into square root of 3. Correct? So 4 divided by square root of 42 is going to be the answer, which implies theta is equal to cos inverse of 4 divided by square root of 42. So you can leave the answer like this. You need not break your head on finding what is the angle. Cos inverse of 4 by root 42 itself means an angle.
Sir, can you scroll up a bit?
Sure. So just go through it. If there is any doubt, any point you want me to explain again, I'll do it. Done?
Yes, sir.
Yes.
That's good. Okay. Now I have to explain why it is so, right? So there's actually a point which is outside this dot product. So with the fourth point, the properties of dot product is over. Okay, I want to add one more point also, which is generally not given. I'm going to borrow the idea from the second concept. I told you a vector dot a vector is nothing but a square, right? See, suppose a vector plus b vector dot a vector plus b vector is given. Then what is going to be the answer? Okay, so two terms and two terms. So totally you will get 4 terms. So it is going to be a vector dot a vector plus a vector dot b vector plus b vector dot a vector plus b vector dot b vector. So what is a vector dot a vector, guys? This magnitude of a vector. No. I cap dot I cap is 1. A vector dot a vector is magnitude of a vector square plus b vector dot b vector is
V square.
magnitude of b vector square. So a vector dot b vector plus b vector dot a vector will be 2 times a vector dot b vector.
Sir, can you repeat this sum, sir? I got disconnected.
Which one? There's not a
This
sum,
fifth
there's a
one.
property. A
Okay.
property. Okay. So a vector plus b vector, the dot product of a vector plus b vector with itself. So you have 2 terms and 2 terms. No, when you multiply both, what are you going to get? A vector and a vector's dot product. So wherever you find a vector, right? If you're doing a product, you can either do only a dot product or a cross product. Since here I have a dot, I'm doing dot product. So a vector dot a vector plus a dot b plus b dot a plus b dot b. Is that point clear?
Yes, sir.
So magnitude of a vector dot a vector from the second property is nothing but magnitude of a vector square. Similarly, b vector dot b vector is magnitude of b vector square. Remember, a vector dot b vector is the same as b vector dot a vector. Okay. If that is the case, then I can write a dot b plus b dot a is 2 times a dot b. Okay. So if you observe, this whole thing is nothing but something
A
similar
plus B
to the
whole square.
parallelogram. Not a plus b whole square. It is something similar to the parallelogram law of vectors. Because when I write it, I will get a square plus b square. I'm not getting 2ab. I'm getting 2ab cos theta. Can I see a vector dot b vector? That is ab cos theta. Guys, are you able to understand? A very big misconception people have is they think it is similar to a plus b the whole square. No. What is this similar to?
This is very much
Resultant,
close
sir.
to
Resultant.
resultant in the parallelogram law of vectors. Actually, the square of the resultant in parallelogram law of vectors. Because resultant in parallelogram is square root. Square of it is without square. Clear? Now I will come to a
So
point
1
which
minute,
is
sir. I will note it down.
Yeah, please do it. Please. I thought you were done. Please do. I hope you're done.
Yes, sir.
Now listen. Listen to this. Magnitude of a given vector. Okay. If I take a vector is equal to 2i cap plus 5j cap. Okay, I'm starting with a two-dimensional point. So I'm saying a vector is equal to 2i cap plus 5j cap, where I'm calling this as a position vector. We have already seen what is a position vector, right? Now see, what will be the coordinates of this point? Is it not going to be 2, 5? Right. So if I call this as OA, then I will drop a perpendicular so that this distance is 2 and this distance is 5. Now what are you able to see, guys? Aren't you able to see a right angle triangle? So wherever right angle triangle is involved, to find the distances, what theorem are we going to apply? It is always parallelogram law of, Pythagoras theorem. So OA square is equal to OB square plus BA square. Accepted? So what is OA square, OB square, guys? Is it not 2 square? And BA square is nothing but 5 square. So this is OA square. Then what is the value of OA? It is square root of 2 square plus 5 square. Am I clear with this?
Yes, sir.
Yes, sir.
Right. So now the question is, this 2 is a coefficient of I cap. This 5 is a coefficient of J cap. So if A vector is given as AI cap plus BJ cap, irrespective of whether B is positive or negative or A is positive or negative, I can say magnitude of A vector is nothing but square root of A square plus B square. Right. In a similar way, if A vector is extended to a 3-dimension, AI cap plus BJ cap plus CK cap, that implies magnitude of A vector is nothing but root of A square plus B square plus C square. Now I hope you guys are able to understand why I did a square root of something over there in the 4th step. Correct? You're able to understand? So this is the formula for magnitude of a given vector in its standard form. Okay. So there are 2 more concepts that are left out in this chapter. One is called cross product of vectors, or it is also called as vector product. And the next last concept the last concept that is left out is
resolution of vectors or components of vectors. Okay. So I'll give you an introduction of what is cross product of vectors. Since we have seen what is dot product, I'll give you an introduction of what is cross product. Okay. And in the next class, I'll explain it in detail because it's a slightly lengthy derivation. It's slightly lengthy. So write it down. If A vector and B vector are two non-zero vectors. When I say non-zero vectors, their magnitude is not equal to 0. Then A vector cross B vector, read as A vector cross B vector is equal to magnitude of A vector into magnitude of B vector into sine theta multiplied with another quantity called as n cap. Okay, if you observe the difference now, what did I write for cos theta dot product? For dot product, it was magnitude of A into magnitude of B into cos theta, but I didn't put any vector beside it. Whereas for cross product, what is the output? Magnitude of A into magnitude of B to sine theta into n cap, where theta is angle between the vectors, and n cap, this is the one which is important. N cap is a unit vector. N cap is a unit vector perpendicular to both A vector and B vector. If I talk about n cap is a unit vector which is perpendicular to both A cap and B cap. Sorry, A vector and B vector. Clear, guys? See, beyond this, I cannot go because I told you it's a lengthy derivation. So I have made a video on this particular concept. If possible, if you guys see before the next class, I can make it fast. Like I've done it with a proper visualization, all those things. I'll share the link in the group today. It is just, I think 13 minutes video, that's it. So in that 13 minutes, you will be able to understand the whole derivation. Just go through that and come before the next class so that when I explain, I can concentrate more on the problems. Because it's slightly a tougher concept. If you have that visualization, I can concentrate more on problems and make things easy for you. Okay. Apart from this, is there any other doubt you guys have from today's class?
Sir, could you please share these notes if possible?
Yeah, I'll do it. See, the only thing, generally what I do is I'll share the notes at the end of the chapter. Because what will happen if I keep sharing on everyday basis, you will get it in chunk wise because I write it in the same document. The same file will get duplicated. But if you want it on everyday basis, I'll do it. I don't have a problem. But only thing is there'll be a lot of duplication works. Okay, which one is comfortable? You tell me. Shall I do it at the end of the lesson or you want me to do it after the class?
End of the lesson.
End of the lesson is fine. Okay. Any other doubt, guys? Any other doubt from today's class or anything from yesterday's class? Everything is clear, right? So I suggest you all to go through this chapter. It is very important. Okay. So once this is over, maximum I'll finish it by Monday. If you guys can go through the video and come, my job is going to be even more simple. Okay. So I can concentrate more on problems. I'll help you out with many problems so that on Tuesday we can start with the fresh lesson. That is units and measurements.
Yes.
Okay.
Yes.
Okay. Okay. I'll see you guys on Monday. If there is any doubt in the
Okay,
meanwhile,
sir.
I hope everybody, just a minute, don't leave. So I hope everybody has made a note of this number. It is 6369210899. Okay. This is the number there's a number exclusively for you guys to ask your doubts. Okay. There's only for student support. I request you tell your parents also to not reach out to me regarding the admin work. There's a number on which I'll be available. This is there only for you guys to ask your doubts and for me to clarify it. in these days, once you revise the chapter, if there is any doubt you have, you can reach out to me on this number. Okay, you will receive the response maximum within 24 hours. Okay,
Okay.
Yes, sir.
I'll see you guys on. I'll see you guys on Monday.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.